Here's problem 6.3. An airplane moves 140 meters per second as it travels around a vertical circular loop which has a 1 kilometer radius. What's the magnitude of the resultant force on the 70 kilogram pilot of the plane at the bottom of this loop? Let's visualize what's going on here. We've got a plane going around a circular loop, and the plane itself is at the bottom. If we were to make a free body diagram on the pilot, we would realize that the pilot had weight, mg, and that the seat of the plane would be pushing on the pilot in the opposite direction towards the center of this circle. So that would be the normal force. And as a result of these two forces, there's actually no force in the x direction because the plane's moving at constant speed, so there's no acceleration in the x direction. But as a result of these two forces, there has to be a centripetal acceleration towards the center of this circle, equal to v squared over r. That's not a force, that's just our acceleration. So that would designate our free body diagram on the pilot. Well, if we were to set this up as an equation, we would say that the summation of all the forces in the y direction is equal to ma, a being centripetal in this case, and that would be equal to n minus the weight. Acceleration being positive in up direction. So we have mass times velocity squared over r is equal to the normal force minus the weight, mg. That is the equation we would set up based on this free body diagram. But we noticed one thing in this problem. It said, what is the magnitude of the resultant force? It's not asking for the normal force or the weight. It's asking for the resultant force, the net force. Well, the net force would be the sum of all these forces together, either n minus mg, or equivalently, mass times acceleration on the left-hand side. That is our net force. So in other words, resultant means net force, our net force on the pilot. So we just need to find the mv squared over r. Now that we got that settled, our net force will be mass times acceleration, according to Newton's second law. In this case, that's going to be 70 kilograms. The pilot is moving at 140 meters per second. So we'll square that. And the radius, this is the radius in the denominator, the radius is 1 kilometer, so that's going to be 1,000 meters. We want to switch everything to SI units. So what does that give us? We got 70 times 140 squared divided by 1,000. That gives me 1,372 newtons. So that is the net or resultant force on the pilot. If I wanted to find the normal force, I could solve this equation over here, and the normal force would be equal to that net force plus mg. So I would add mg to this 1372, and that would give me the normal force, but that wasn't asked for. So we were just asked for the resultant force, 1,372 newtons.